Good morning. Sorry I couldn't be there today. I hope this works out pretty well. I know it won't be perfect, but I appreciate you giving it your best shot. As we go through the notes today, obviously I'm not there to answer your questions, but I'll try to be really clear when I'm explaining the problems and concepts. If at any point, and I'll remind you of this, you write something down and you're not really sure where it came from, go ahead and put a question mark by it so that when you look at your notes when I come back on Monday of next week, you can go through some of those question mark problems and ask me, or you could just ask your neighbor during work time today and go over some of those question mark problems. So as we go through the notes, if you're copying something down and it's not making sense, put question marks on your notes as a reminder to yourself later to figure those out. All right, so we've got 4 videos for today. I'm going to try to make them not super long, just so that you have more time to practice. I will put these on the Google Classroom, so if you want to go back and watch any portion of it as a refresher, you can do that on your own time. So let's give it a shot and see how it goes. All right, so first page, here we go. So you should have the handout, and it looks like this. Up here at the top, we've got reminder of the different exponent properties. We have done, we did these last class. And after we do a warm-up over these using those concepts, these will be the new ones today. All right, so let's start with a warm-up. Go ahead and we've got 9 problems here on the page. Let's set a timer for 10 minutes, no more than 15. Pause this video, work on it, try to write something down for each problem, and when you unpause the video, there will be answers on the page. All right, and then then you can check your work and ask some questions. All right, so all right, let's go ahead and pause the video now, and let's set a timer for about 10 minutes and see if you can at least write something down for each of these 9 problems. All right, good luck. Boom! There you go. Answer key right there. So why don't you take a look and see what you got. Now that you know the right answers, I may have made a mistake, but I think these look pretty darn good. Go ahead and mark the ones off that you didn't get, or that you weren't able to get. Either circle them or put question marks by the ones that don't understand. At this point, you can move on to the next video after everybody's checked their, pause this, grade it, ask a few questions if you want, and you can move on to the next video if you like. I will go ahead and solve each problem and show the steps. So move on to the next video if you want, but if you want to see the steps for each one of these, you could fast forward to the problem you want to look at, and I will try to explain it as I solve it. So, so I'll go ahead and show how to do these, but if you're feeling comfortable, you got most of these right, or all of them right, go ahead and go on to the next video, which will start the new material. So this is a warm-up from the day 1 material last class. All right. So I'm going to go ahead and solve these if you're sticking around to watch this video. The first problem, anything to the 0 power is 1, positive 1. So this whole thing is to the 0 power, so that's why you have a positive 1. In problem number 2, that 5 is to the 0 power, but this negative does not have that 0 power. This is kind of read as the opposite of 5 to the 0, so the opposite of 1. And that's why the negative 1 is your answer. So those have to do both with the first property, which is the 0 exponent property. So number 3, negative exponents. If I look up at my rule, up here at the top, negative exponents become positive when you take the power and move it, if it's in the top of the fraction, the numerator, move it to the denominator. So my in-between step for number 3 is I take that 3 to the negative 5th, and when I put it in the denominator, that base of 3, the exponent becomes a positive 5. And so I can just reach for my calculator and type in 3 to the 5th. and get 243. Number 4, this looks like I am multiplying, so multiplying the bases. This is x to the 10th times x to the 3rd. If I look up here at the top, the product of powers says when I multiply two powers with the same base, I add the exponents. So I'm going to add 10 and negative 3, which is just 10, I guess I'll write 10 plus a negative 3, and that's the same as 10 minus 3. So that's where you get x to the 7th. 10 minus 3 is 7. So that's the product of powers. The next one, it looks like we're dividing. There's two ways to do this, really, and they're both totally correct. I could use my negative property, which says, if I have a negative exponent, changing the location would make it positive. So if I took this power in the denominator, the bottom of the fraction, if I moved it up, this would become y to the positive 4th. So this is already have one y to the 1st up there. So now I have one y and then multiplying by 4 more. So that then goes back to my product of powers. So when I'm multiplying the bases, I add the exponents. So that's why I get a 5 there. Here I'm going to use, on number 6, I'm going to use my quotient property, which says subtract, right? When you're dividing 2, you subtract the exponents. So I noticed that, zoom in on this, whoa, that was weird. I can do 2? Oh, look at that. I didn't realize I could do that. I'm not pointing anything particular here, just didn't know I could do that. All right, so here I've got x's that are divided and y's. So what I notice is there's more x's on top. I have x to the 3rd. There's a higher exponent on top. So that's x to the 3rd on top. And the bottom, there's an invisible 1 there. That's x to the 1st power. So when I subtract that, the exponents there, I'm going to subtract on the top because the larger exponent is on the top. So it'll be the top minus the bottom. So there's more on top. For the y's, the larger exponent is here on the bottom. So I'm going to leave this one here, and I'm going to bring this down and subtract. So that will be y to the 5, we were looking 5 there, 5 minus 2 power. So that's where I get my 3. Another way just to think about this is if I ignore what I know about the exponent properties and I just think about what that exponent means. The exponent means multiply a certain number of times. So x to the 3rd looks like this, and y squared looks like this, all multiplied together. And then the bottom has an x, and it has 5 y's, 2, 3, 4, 5. So if I didn't have such a thing as exponents, this is how I'd have to write it. And it's useful to think about that when the numbers are small, because anytime you have something divided by itself, the x on top of the x here, that cancels because it equals 1. So, and multiplying by 1 doesn't do anything, so we can just make it go away. And then I also have 2 y's on top that will cancel with 2 y's on the bottom, because those will also make 1, anything divided by itself. So what I'm left with is x squared on top and y to the 3rd on the bottom. So that's an alternative way to think about it. Okay, number 7. The 2 is just, this 2 out here is kind of just waiting. It has a power of positive 1, so maybe I'll put that there. So that's just kind of waiting. This part right here is my power of a power rule. Right here, when I have a power of a power, that multiplies. So I'm going to multiply these 2 powers, 4 and 2, to get rid of the parentheses. So I'm going to rewrite this as my coefficient 2 is still out there, but then I have x to the 8th. Okay. Let's see here. Well, I guess I could write it as, I'll write it a little bit differently. This will be x to the 4 times 2, right? Because it's a power of a power, so I multiply. Number 8, again, I'm going to have to do this first because that's a power of a power. It's sort of like order operations. You have to open up those parentheses before you can combine it with the m squared out front. So I'm going to multiply. I've got the m squared waiting, and then my power of power rule says multiply 3 times 4. So I have m squared and m to the 12th. Now this is just my product rule, which tells me to add them up. So that's where the 14 comes from. Last one, look at all those negatives. All right, so when I have a bunch of negatives like this, it's easy to make sign errors and mess stuff up. So I like to use the negative property. Oops, don't want to point there. I like to use the negative property and just make all my exponents positive, and then they're kind of easier to think about and deal with. So I have 4 bases here. 3 of them have visible negative powers. The x on the bottom has an exponent of 1. So I'm going to just go ahead and mark that. So now I'm going to move all my negative exponents to make them positive. So the first exponent, x to the negative 3 on the top, that will come down here to the bottom to become a positive exponent. So I just moved this power right here to the denominator to make it positive. Same with this y to the negative 2. It has a negative exponent in the top of the fraction, so if I bring it down, that will become positive 2 for the exponent. The order doesn't matter because it's all multiplication. I see that there's an x to the positive 1 that's already in the denominator, so I will leave that there because it has a positive exponent. It doesn't need to move or go anywhere. And the last power I'm dealing with is this y to the negative 5th. Again, a negative exponent means we need to move it to the other side of the fraction bar. So this one's at the bottom, I'll move it to the top to make that a positive y to the 5th. So now I've got a couple things. I've got my x's, which are side by side on the bottom of the fraction. So that uses my product property, which says add up the exponents. So that'll be a 1 plus 3 for that power. And then my y's are using ones on the top and ones on the bottom. So that's my quotient rule, which says subtract the exponents. So I will make that y to the 5 minus 2 on the top because these two here are a quotient. That means divide, right? They're divided. So then when I simplify, the top is 5 minus 2 is 3. So that's what I have here. And then the bottom has x to the 1 plus 3, which is 4 there. So I'll zoom out and just show it all here for a second. And then I will start the next video for a couple of new examples.